Okay, chapter 9, we're starting with our transformations. Today we're doing some reflections, some translations, and some dilations a little bit. We're doing it all on the graph, and the point of the homework assignment after last time was to see if you could figure out the rules for, like, if you wanted to reflect the point over the x-axis. You are going to have to memorize these 4 rules. So did you end up seeing what happened? What's kind of weird is they don't call this, like, that's not a highlighter. They don't call this, like, XY. They call it AB in these generic rules. But look what happens from AB to, like, if I reflected over the x-axis, became that orange guy. What happened? We're going to write, like, the rules in English here. What happened from the green point to the orange point? Well, it definitely went over the x-axis. What happened from AB to A negative B? Like, what happened? Somebody's sign changed, right? It doesn't necessarily becomes negative. I know in the rule it's written that way, like it looks negative, but if B was a -1, wouldn't it become like a +1 in that case? So instead of calling it B, though, I like to let my brain go that would be Y's sign, right? So let's kind of put those notes for ourselves, that to reflect something over the x-axis, you change Y's sign. And I was hoping that you'd figure that out after all those problems that I gave you after the tests. So we're going to change Y's sign. So how about if you reflect over the y-axis? What do you think the rule is going to be on that? Change X's sign. I call that kind of like opposite game. You know, if you want to reflect over the x-axis, you're going to change Y sign. And if you want to reflect over the y-axis, you're going to change X's sign. Those were stuff I think you could have handled without a teacher. When they want to reflect over some other fancy lines, like the line y equals x or the line y equals -x, there's some fancy things that need to happen. So I got a visual of that going on for you. Man, it's been a while since you probably graphed a line, you know, but check it out. Doesn't this line right here have a y-intercept of 0? Are you cool with that? And if I was to count the slope, you know, I could rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Doesn't it have a slope of 1 in that case? Isn't that this line right here? Slope of 1 plus 0. But that's just like so weird to write it that way. Isn't this the line y equals 1x plus nothing? Isn't this red line the line y equals x? Yes, no, maybe? If I would like to reflect this point right here over the line y equals x, first question, would it go over here? Yes or no? Is that where it would go? Nope. Doesn't it need to go like right there-ish? You know what I'm saying? So here it is. There's that point reflected. I'll do that again with that purple point, that -3, 1. Shouldn't it go like right there? Can you see what happened? What happened between the ordered pairs? Between, like, this is a 2, 3 to start with, now it's a 3, 2. This is a -3, +1, this is a +1, -3. What happened? Didn't it just, like, switch places, you know? You know why? Because we let y equal x. And you let x equal y. Isn't that literally what this says? Hey, whatever y was, let it be x. And let x be y. So that's the rule on reflecting a point over the line y equals x, is x and y switch places. X and y switch places. X and y switch places. And you can see it in the rule. It started as AB. It became BA. Do you see how they just switch places, right? If you're going to reflect over the line y equals x, you're going to let y equal x, and you're going to let x equal y. And then how about reflecting over the line y equals -x? This is the line y equals -x. He's got a y-intercept of 0 and a slope of -1, right? So shouldn't this dot right here come over here in that case, right? And same thing right there. So there it is. 2, 3 became, -3, -2. And 5, -2 became 2, -5. First question, are the signs the same or are the signs different? Signs are different, right? This was a +2. It is now a -2. This is a +3. It is now a -3. Places, did they stay the same or did they switch? They switched. That's the rule, man, is change both signs, then switch places. Change both signs, then switch places. Man, I hope you wrote these rules down in English, because later this chapter we have some rotation rules as well on a graph, and it gets complicated. There's 3 different rotation rules we're going to do. There's 4 reflection rules we got to do. Here's what you got to memorize. These 4, right? I'm not going to make you memorize all 7. I've tried that in the past. It was a nightmare. To memorize 7 rules that are just way too similar, it was dangerous. So we're going to memorize those 4 rules right here, and let's do a quick little bit of practice. This will be just like the test. What we'll learn in this chapter is a lowercase r, like they have written right here, means we would like to do a reflection. So little r stands for reflection. And then they're going to do it over some sort of line right here. You see that they have the y-axis right here. So what's my rule to reflect just a plain Jane point over the y-axis? Change x's sign. So what would 4, 3 become if we reflect them over the y-axis? -4, +3. Do you need parentheses? Yes. Do you need the comma? Yes. We're writing it as an ordered pair. So here, they ask us to reflect the point 2, -1 over the line y = x. Again, please get these memorized by the time you're done with your homework, coming in next time that we have these rules memorized. But to reflect over the line y = x, don't you just switch places in this case? So wouldn't that go with -1, +2? And then I'm going to do one more with you, and then kind of turn you loose on the last 3. To reflect over the x-axis, the rule says we just got to change y's sign. Right, so that would be -3, +9. Why don't you pause the video and try 4, 5, and 6. To reflect over the line y = -x, I should change both signs, then switch places. It's kind of weird that it's still -6, -6, even though they switched places in that case. And then I'm going to skip number 5 and come back to him. What did we get on 6 if I reflect -2, +2 over y = x? Yeah, they just changed places. But what the heck happened on number 5? To reflect over the y-axis, we're supposed to change x's sign. X is 0. 0 is the only number that is neither positive nor negative, right? So it doesn't have a sign. So it just stays 0, -3. And here's my question. How can it stay the same? What does that mean? I kind of have a graph sketched to show you. What does that mean? Talk to a neighbor about it. What does that mean? It didn't go anywhere because isn't 0, -3 like right here? It's on the line that we're trying to reflect over, right? It's on the y-axis. So if you're on a line that we're trying to reflect over, you're going to move nowhere. Shouldn't you reflect to yourself in that case? Sound all right? So nice. That's reflections. Now let's do this. Let's graph triangle ABC. So let's do this and use it to reflect over some indicated lines. Hey, before we graph ABC, check it out. What are they asking us to reflect over? The line, the x-axis, the y-axis, y = x, or y = -x? Okay, I'm going to make you graph that line first, right? So let's start at 0 for a y-intercept. And he's got a slope of -1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Just put your 4 points, then take the straight edge and connect those together. Once you get the line y = -x graph, then graph ABC. And here's the thing you're going to want to do. Put the letters next to it. A is at 3, 1. It's been a long, long time since we plotted points. Make sure you get 3, 1 in the right spot. A lot of times people accidentally go to 1, 3 instead of 3, 1. 3 on the x-axis, 1 on the y-axis. Put a capital A there. And B is at 4, 3. Capital B, and C is at -5, -2. It's supposed to be a triangle, so take your straight edge and connect those 3 points together. Then what they got for us is this thing that I don't think we've seen before. I could be wrong. But you see, like these 3 points were A, B, and C. They're asking us to find what's called like the image of those. They have this word apostrophe. Have we called that prime before yet this year? That's A prime, B prime, and C prime. We're going to have to learn it because it's the whole chapter. So like if A reflects over a line and it doesn't tell you what to call it, you're just going to call it like A prime in that case. And if B reflects over a line, we're going to do B prime. So let's use the rule. Isn't the rule for reflecting over y = -x, we got to do what? Switch signs and switch places. So A is at 3, 1. What would it reflect to? -1, -3. Yep. Then B, get that bad boy, change both signs and switch places. And C. Then we'll plot those guys, and it gets a little messy because we've got to put those primes. So A prime is at -1, -3. We'll put A prime. And before I go any further, I let my brain tell me if I did it right. Does it look like A and A prime reflect to each other over that line y equals -x? Because if it doesn't look right, I'm either plotting points wrong or using my rule wrong, you know? So it's like B prime will be at -3, -4. So I'll put my B prime right there. And then C prime will be at 2, 5. Then connect those together with your straight edge. And some people like to highlight the new guy a different color because it just looks too pencil-y gray. You'll see that when we start doing dilations especially, that it's nice to highlight. I always do mine in different color up here so it's easier to see, but if you want to highlight, you are welcome to. You don't have to, you know, but it just like it helps that visual brain for a lot of people. So let's see if you can do that on 8. First, graph the line that they are asking you to reflect over. They are asking us to reflect over the line y equals x, so I'm going to graph the line y equals x. He has got a y-intercept of 0 and a slope of 1. So, boom. And then plot triangle ABC. Once you get triangle ABC plotted, then totally find A prime, B prime, C prime with the rule to reflect over the line y equals x. You just switch places. So A prime will be at 1, -2. B prime will be at 6, 3. And C prime will be at -4, +1. To reflect over the line y equals x, those switch places. And plot them and connect them. And then on the test, I'm going to have you highlight just because it makes it easier for me to grade, you know, and I know which one was which, but on homework, I don't care. It's your choice. And I plotted those, and I connected them together. So I plotted those. I got a question for you that's going to really make next time go a billion times easier. We've done 2 reflections so far. Talk to me about, first let's get some vocab words out of the way. Do you see the blue ones up there is the original guy, the OG? That's called the pre-image, right? The pre-image. If you go to the movies, what's a preview? Does that happen before the movie or after the movie or the movie? Preview. Before the movie. So like pre-image is before you've done anything, right? You know, before you've done anything, that's the pre-image. Then the green thing is what you made, right? That is the reflection. That is the image. But here's the real question. Talk to me about both of them. Are they same size, same shape? Yeah, they just got flipped over, right? You know, it shouldn't get any like bigger, smaller, or weirder or anything like that. So reflections should keep things same size, same shape. Let's do one more, baby. Which line do they want you to reflect over? Y equals -x. So let's plot the original guy, graph that line. The only time you don't have to graph the line you're reflecting over is if the x-axis or y-axis. It's already there. You know, it's part of the graph. But if they ask you to reflect over y equals x or y equals -x, we'll do that. So why don't we pause the video and give that a shot. So I've graphed the line y equals -x, and the rule is to change both signs and switch places. And what I have is sort of a bad thing. I did it on purpose. So I have the right drawings, but I have, like, which point was on the line? A and A prime. I have 2 different points names for the same point. You shouldn't do that, right? So he's just going to be A. And I did that on purpose because I'm sure we would also put both of them. You can't be like one point names two different things, so do not call him A prime, and then it's just sort of like a bad part of the question that I know the answer is asking for A prime. He's really just going to be A in that case. A would turn into A because it reflected to itself. So anytime that happens, don't make up a primed point for it, even though the question probably had a prime there. It's like, well, we have to trump that because it's on the line that we reflected over. Cool? Yes? Which one? B prime? I did. It should be over here. All right, 1, 2, 3. It should be like right there, huh? Yep, I got B prime in the wrong spot. So I'll use a straight edge, connect those together. Thank you for noticing that. So, cool. That's a reflection, right? Hey, did they stay same size, same shape? Cool. Let's go into translations. They use a vector. If you're into some big-time science classes, they talk about vectors all the time. A vector is just where something moves in math class. So the cool thing is they don't use, they have different ways to write it. Sometimes they write it with a rule. Sometimes they write it with these vector brackets right here, which are not parentheses. They're like pointy brackets in this case. The first thing right here that I have in blue is going to move you like left or right. And then the second thing that I have in pink right here will move you up or down. So here's what this means. This blue thing is going to take all of our x coordinates and move them 2 units to the right. How did I know it was to the right and not to the left? What do you think would it have to be to make it go left? A negative value. So all this means right here is I need to take and add 2 to all of these x values. And because they're asking me to do the same rule on all of these, I personally just go do all the x's first. Because isn't the rule plus 2, right? Plus 2. So it starts at 2, add 2 to it. Where would that go to? 4. Then I'm going to jump over here. It starts at negative 1. I'm supposed to, the rule says add 2 to it. So that would be at 1. And then it starts at negative 9. Careful, we're going to add 2 to it and get to negative 7. I personally just like to do all the x stuff first because my brain's like, okay, just add 2, just add 2, just add 2. What are we supposed to do to the y's? Subtract 1, which is going to move it down 1. So I'm just going to go and subtract 1, subtract 1. Don't need a comma twice, though. And then subtract 1. Do you see how like I outsmarted the rule? Since they had me use it 3 different times, it's like, why not do all the x's first and all the y's second? This moved it 2 units right and 1 unit down. So let's do that here. Let's graph triangle J. So here we go. D's at 1, 2. And A's at 4, 3. And Y is at 2, negative 1. Could call that A instead of 3. Connect those together. Connect those together. Then they asked me to go along this vector of negative 3, negative 4. This means it's going to move 3 units to the left and 4 units down. Do you see I did left because it was a negative and down because it was also a negative. They asked me to find all these ordered pairs, so honestly, bro, I'm just going to do that first. I'm going to take all of these ordered pairs right here in pink, and doesn't the rule say subtract 3 from it, right? So I'm going to do all my x's first. Just subtract 3 from all those guys. So 1 minus 3 is negative 2. 4 minus 3 is 1. And 2 minus 3 is negative 1. Then do your y's. The y rule is to subtract 4 from all of those guys. So basic arithmetic with these. And then check them with mine. Make sure I did it right also. I do make mistakes. If you have those correct, plot D prime, A prime, and Y prime. So D prime is at negative 2, negative 2. A prime is at 1, negative 1. If I could plot these in the right points, wouldn't that be awesome? Got that right there. A prime And then y prime is at negative 1, negative 5. 1, 2, 3, 4. Kind of a weird scenario here to do that because it's like I didn't need to do this at all, except for the fact that they asked me to. They asked me to find, hey, where's b prime, where's a prime, where's y prime? Would you believe we could have just started with the pre-image and moved it 1, 2, 3 units left and 1, 2, 3, 4 units down and still found d prime in that case, right? So you just do that to all 3 points and then you connect them together. So again, notice they said graph triangle day. That was the pre-image. And then its image was the final guy. Pre-image is what you start with. Image is the other guy. So let's do that again. Here's what I need from you, though. I hate that I don't have letters on these guys right here, so let's put some letters on them. Let's call this A, B, C, D. And then we might as well get like 7 and 8 done. Notice I went A, B, C, D, E kind of around the clock. If you start at the top, calling that an A. And then on 8, I did A, B, C. So they tell me it's a translation, which is a slide, right? And they wrote the rule differently this time. They didn't put it in the vector brackets. You started with x, y, and it becomes this blue thing right here. They just are literally telling you what to do in this rule. So do you see how it says x minus 4? What does that mean to you? Move it 4 units to the left, right? And then this guy right here, y plus 2. So they don't have me write the ordered pairs of the new guys, so I don't need to do that. I'm just going to start at A and go 4 left, 1, 2, 3, 4, and 2 up, 1, 2, and call that A prime. Just do that for every one of those guys. Move it 4 units left, 1, 2, 3, 4, and 2 up, 1, 2. And then that would be B prime. 1, 2, 3, 4 units left, 2 units up, C prime. 1, 2, 3, 4 units left, and 2 units up, D prime. Then connect those together, which is more challenging than you think to connect those together. When there's 3 points, it's not that hard at all. When there's 4 points, it's okay. But boy, when we get 5 points, 6 points, 7 points, it is interesting. But you connect those guys together. And we'll talk about something before I turn you loose on the other 2. The thing I would like to talk about is if you just take something and slide it, either left, right, or up, down, or a combo or both, should it be same size, same shape? Yeah, it should be congruent, like it's not going to change. Yes? Say again. Let's try the next guy right here. So just tell me what this means. What does this guy right here mean? Move it where? 5 units right, and the other one is 1 unit down. All right, so I'll get that done. 5 units right, 1 unit down. 1, 2, 3, 4, 5. 1 unit down. Use a different color. A prime. 1, 2, 3, 4, 5 units right, 1 unit down. B prime. 1, 2, 3, 4, 5 units right, 1 unit down. C prime. And 1, 2, 3, 4, 5 units right, 1 unit down. And oh no! B and D prime end up on the same spot. They are different though. It didn't like translate to itself, so we will have the 2 different letters. Like it's not B and B prime, it's B and D prime, so we'll have it. Then see if you can connect those guys together. Thank you. See if you can connect those guys together. And let's see, what do you think about that? I kind of hit pause there when I shouldn't have. So make sure you connect the dots together correctly, how they were connected from the original. A to B, A prime to B prime, and B to C, B prime to C prime. And then all that happened on number 8 is it moved 4 units up because it didn't go anywhere right there. Feel good with translation.